Hello everyone, and welcome back to another session on seismic analysis with IS1893. I am Surajit Ghosh, and today I will discuss about time period calculation for buildings with reinforced concrete and URM infill wall, and how to define this wall information in STAAD in different direction. When a reinforced concrete or masonry wall is considered for analysis, stiffness and load path is modified, which eventually change the time period of the structure. How we can consider the wall stiffness using few additional input, that I will cover in detail. In last video, we have discussed about time period calculation for different structure using few empirical equations mentioned under clause 7.6.2. For static seismic analysis, eigensolution method is not used, which considers the effect of different structural element for time period. Rather, 5 different empirical equations are used to calculate the approximate natural period depending on different framing system. First 3 equations are used for bare MRF building without any lateral load resisting wall, and last 2 equations for lateral frames combined with other load resisting element including reinforced concrete and masonry wall, bracing, damper. Instead, we can define different structure type and use any of this equation for time period calculation using ST parameter. ST1 to 3 is used for bare moment resisting frame, which we covered in the last video with few examples. For any high-rise building, only a moment resisting frame is not sufficient. Due to larger height and weight, any tall structure is subjected to higher seismic force. To resist this force and minimize the lateral drift, we need a more rigid lateral frame with shear wall, bracing or dual framing system. Use of reinforced concrete wall in a lateral frame at different location and direction is quite common. When a RC wall is included in a frame along the load direction, lateral stiffness of the frame is increased. Any wall which is not in line or perpendicular to the frame does not provide any significant resistance to a lateral force applied along that direction. This is obvious as the stiffness of the wall against that lateral force is negligible. How the seismic force is transferred using diaphragm action and resisted by a shear wall, that will be covered later. This lateral frame with reinforced wall has higher stiffness, which reduces the time period of the structure. Time period is inversely proportional to the stiffness, right? For static seismic analysis, we can calculate the time period considering stiffness of the wall using equation B of clause 7.6.2. It is similar to the first equation for RCMRF building. Only difference, we are dividing the calculated time period with a factor AW, which depends on the wall dimension. AW is the effective cross-sectional area of the wall, which is calculated using this equation. Well, there is a lot of confusion about this. In the original version of the code, which was published in 2016, this equation was provided. Later in Amendment 1, published in 2017, it was modified, and the square term was provided outside the bracket. With this modified equation, calculated time period was quite large, which significantly decreased the seismic force. Later in 2020, second amendment to IS1893 Part 1 was released, and in this version, this equation has been modified back to the original. The square term is inside the bracket. This is the final equation which we need to follow. For AW calculation, length, width, and height of the wall is required. Length of the wall is considered in the direction of lateral force, which we have already discussed, and full building height is considered as the height of the wall. Also, we need to consider the walls located only in the first story of the building. If the dimension or location of the walls are different in other story, then also wall data for first story is used. Under table 5 and 6, it is recommended to avoid any plan and vertical irregularities. Discontinuous or modified wall dimension is not suggested. We assume that the walls at first story is continued till the roof, If the walls are irregular in plan or elevation, then we need to use dynamic analysis to consider the stiffness variation of load-resisting frames. Do you know how we can define all this data in STAAD? Consider this model. I have modeled few shear walls using plate mesh in both X and Z direction. These walls are regular in plan and elevation without any irregularity, and I want to use this for time period calculation. I have already saved an isometric view of the first story, and anytime we can access it using view management to collect wall data. Length of wall along X direction is 9 meter each, and along Z direction is 8 meter. Thickness is 250 mm. We need to consider the wall area along the load direction. When seismic force is applied along the X direction, these 9 meter walls resist that lateral force, and when load is applied in the Z direction, 8 meter walls are used. To consider this, first we need to define the structure type as 4, which refers to equation B. Then we need to inform STAAD about different wall dimension. Though we have modeled the walls using FEM, program doesn't use this plate mesh information. If we don't provide any wall information and simply analyze the structure with ST4 parameter, a warning message is reported in the output, which suggests to provide required wall data. In such case, when wall information is missing, time period is calculated using equation 0.09h by root d. To avoid this and consider correct wall dimension for time period calculation, we need to provide wall inputs from the seismic definition page. This wall area option is available only for IS1893 2016 code, not in any older version. Here we can define the wall width and length in each direction, one by one. For example, in X direction, we have two walls. Width is 0.25 meter and length is 9 meter. In Z direction, width of each wall is 0.25 meter and length is 8 meter. We can add this and program stores the wall data in each direction separately. This information are used for AW and time period calculation. Let's take another example. Same model, but the wall arrangements are different. In X direction, there are 4 separate walls at the periphery. Also, there is a lift core with reinforced concrete wall. In Z direction, there are 2 lift core walls. To consider this for time period calculation, we can provide each wall information separately, one by one. Also, we can create an Excel file with all wall inputs in each direction. From here, we can copy the wall data and paste it directly in this table. First for X direction, then for Z direction. Copy and paste. Easy, right? Dimension of all existing concrete wall in the first story is provided, and program considers this wall data to calculate the time period as per clause 7.6.2b. Use of different type of framing system in different direction is quite common. For example, in this model, there are few concrete walls in X direction, but there is no wall along the Z direction. Construction cost of a concrete wall is quite high, and we need to use these walls only when it is required. For this type of framing system, we need to provide required wall dimension in X direction only and skip any data along the Z direction. During time period calculation, equation B will be used for X direction and equation C will be used for Z direction. One last point. As per IS1893, time period of RC wall is compared against the time period of all other building, which is basically meant for building with brick wall or bracing, and the larger value is considered. There is one interesting fact about this comparison and how this is actually implemented in STAAD. that I'll cover later in the validation problem. By the way, we can provide wall information and consider equation B for time period without even modeling the wall using FEM. But it is not a correct approach as stiffness of the wall is not considered during analysis. That's all about time period for buildings with concrete wall. We have already discussed about bare MRF frame without any additional load resisting element and frames with concrete wall. There are few other types of load resisting frame like frame with bracing, which is commonly used in any steel structure, or frame with infill masonry wall, which is also very common for any residential or commercial building. Time period of any such building with other type of load resisting element is calculated using equation C with ST5 parameter. When you design any concrete building with infill brick wall, most of the time we neglect the effect of the wall and assume this as a non-structural element. Load from the wall is applied as a dead load, but stiffness is ignored. It is a conservative approach. Any thick masonry wall with adequate strong material like brick provides enough lateral stiffness and contributes significantly to resist lateral force. If we model these walls properly and consider the stiffness during analysis, it can reduce the lateral deflection and overall reinforcement percentage in the structure. Normally these URM infill walls are modeled as equivalent diagonal strut, as suggested under clause 7.9 of IS1893. If we want to optimize the design result, it is better to model and consider the lateral stiffness of masonry wall. In few of my projects, I have followed this approach and reduced the steel usage. We can use equation C and ST5 parameter for any building which has frame with infill brick wall or bracing. In last video, I have discussed about the structure type of this model. Just to clarify, this concrete building has no infill wall. This type of structure is very common for any office building or shopping complex where a glass cladding is used in the outer periphery, and for internal partition wall, blockboard or inferior material is used which has negligible lateral stiffness. We can consider such type of building with thin brick wall or partition wall as MRF building and use ST1 parameter. But for any residential or other concrete building where 8 or 10 inch or higher thickness masonry infill walls are used, we need to define the structure type as 5 to consider the lateral stiffness of the wall for time period calculation. One thing to note, it's just an empirical equation using which we are considering the wall stiffness for time period calculation without even modeling it. Wall thickness variation, opening or presence of a wall does not impact this time period. Internal frames without any wall or with 5-inch thick wall is quite common. In such case, where the thickness or presence of wall vary, we need to model the walls properly as equivalent strut and use a proper dynamic analysis. Also, under table 6, code clearly informs to model the infill masonry wall when structural plan density of wall is greater than 20%. Before finalizing the model, we should calculate the SPD of wall of any floor and accordingly model it using equivalent diagonal strut. I'll cover modeling of URM infill wall later in this series. Consider this PEB warehouse that we have discussed in the last video. For this structure, there are few lateral frames with bracing. These braced frames are a part of lateral load resisting system when seismic force is applied along Z direction. But most of the frames in this direction are not braced, and in X direction, no bracing is provided. That's why we have considered the structure type as 3, ignoring the bracing. We can define the structure type as 5, but that is not a good solution. For such model with different framing system, it is better to use dynamic analysis. By the way, in Amendment 2, a new condition has been included under clause 7.6.2.1, which limits the maximum and minimum value of calculated time period. In equation B and C, two building data are used: height of the building and base dimension at the plinth level. By default, STAAD calculates the height of the building from the lowest support level up to the highest Y level. But it is not true for several situations as highlighted in figure 5. For underground structure or structure with multi-level basement, we need to consider the height of the building from the ground level. Also, base dimension might be different at different support level. How we can use custom height and base dimension for time period calculation? That I will cover in the next video. Thanks for watching.